Welcome to the LMWC Learning Mathematics with Ms. Choekyi channel. Please do hit the like button and subscribe the channel.
Hello everyone. So today we are going to start the second chapter, which is polynomial. So in polynomial, first let us quickly try to understand the definition of the word polynomial. So a polynomial is an expression which consists of constants. So when we say constant, we meant a fixed number. So a fixed number means all the real numbers, and variable means, as the name says, the number keeps on changing. There is no fixed number. So therefore, we use the variable x, y, z, the alphabetical letters, and the exponent. So here exponent means the power, right? So exponent, which is a non-negative integers, which is also equivalent to the whole numbers, right? So an expression which contains a constant, variable, and exponent, where exponent is a whole number, then such expressions are called as polynomials. All right. So let's say I have an expression 3x to the power 5. If you look at this expression contains a single terms. So terms are differentiated by plus and minus. So as you see, between 3 and x to the power 5, there is only a multiplication. So this is one single term. So in this term, if you look carefully, this number 3 is our constant, or you can also call it as coefficient. And this x is our variable. And this 5 is our exponent, which is a positive integer. So hence, this 3x to the power 5, we can call it as a polynomial. All right. So let's say I have two terms. So 3x to the power 5 minus 2x. We have two terms because the moment you have added a plus or a minus sign, that will divide the expressions into terms. So the first 3x to the power 5 will be the first term, and minus 2x will be the second term. So if you look at the one single terms, what you can find is 3. We have 3, which is constant. We have variable x. We have exponent, which is positive. Similarly, I have a constant over here, negative 2. Negative 2 is our constant. X is our variables. And this x has a power. Nothing is written means the power is 1. So this is our exponent, and 1 is a positive integers. So hence, this both the terms together, this whole expressions, again, it gives the polynomial. All right, the general form of the polynomials can be represented in this way. If you look at here, all this a is your constant, and all this x is your variables, and all the powers are written up here. And if you look at the few other examples, the first one, p of x equals to x plus 4. So this x plus 4, this expression contains two terms. So first term is x, second term is plus 4. Now, x, as I have said before, this x has a power 1 because nothing is mentioned means there is only one x, and before the x there is 1. Number 1, 1 times x is x. So here again, 1 is our constant, x is our variables, and 1 is our exponent, which is non-negative integers. So similarly, if you look at the number 4, I can also write this as x to the power 0. So 4 is our constant, variable is x, and exponent is 0. So why I have chosen x to the power 0? Because any number with a power 0 is equivalent to the number 1. So that means 4 times 1 is 4. So I can either write it this way or write it this way. So as you see, this 4x to the power 0 satisfies the definition of the polynomials. So this 4 must also satisfy the definition of a polynomials. So generally we name this 4 as a constant term. So term which does not contains a variables. Although there is a variable x, we can write it in this way, but it has no meaning because x to the power 0 is 1, the number 1. So hence, here in the x plus 4, this is a polynomial, and if you have to differentiate in the term, the first x is the first term and the 4 is the second term, and 4 will be your constant term also. Similarly, if you look at the f of x equals to 3x squared plus x plus 7. So you understood the definition of polynomials. So generally what we will do is we will focus mostly on the power or the exponent of the x, of the variables. So the variables, the exponent has to be positive. either positive or 0. So here in this case it is +2, this is +1, and this is 0. Similarly here this is power is 3, power is 2, power is 1, and here power is 0. So therefore a polynomial is an expression which consists of constants, variable, and exponent, which is a non-negative integers, and we can write it in this way. All right. So the next topic we have geometrical meaning of the zeros of polynomials. So in this topic, what we are going to learn is how to take out the zero of a polynomial from the graph. Okay, so the zero of the polynomial, it is the x coordinate of the point where the graph intersects the x-axis, the point which touches the x-axis. So our x-axis is the horizontals, right? So the graph which you will plot, if it touches the x-axis, that point, from that point you just need to take out the value of the x. Okay, so let's say I have given this y equals to x squared minus 3x minus 4, and this is our quadratic polynomials, right? We can name this as quadratic polynomials because the highest degree over here is +2. So now this quadratic polynomials, if I represent it on the graph, I will get this shape, this parabolic shape, right? So now if you look at this, this touches the x-axis here one time, and this parabolic, it keeps on going like this, and again it goes, and again it touches the positive x-axis. So which means I can see that this parabolic touches the x-axis one time over here, which is -1, 0, and the second time it touches the x-axis, the coordinate point is 4, 0. So these are the 2 points which touches the x-axis. Now from these 2 points, what I need to take out is I need to take out the zero of the polynomial. So zero of the polynomial means that at what value of x will the y become 0? So which means here in both the coordinate points y are equal to 0. So when you put the x as -1, you are getting 0. Similarly, when you put the x equals to 4 in this equation, what happens is y will be equal to 0. So for value of x equals to -1 and 4, our y becomes 0. Okay, so hence the geometrical meaning of the zero of the polynomial means whenever you are given a polynomials, you have to plot it on the graph, and you just need to take out the point where it touches the x-axis. So next topic we have relationship between zeros and coefficient of a polynomial. Let's consider a polynomial p of x equals to ax squared plus bx plus c. So this a, b, c, these are the coefficients of the variables. And let's say alpha and beta are the zeros of these polynomials. Okay, so if that is the case, then we have few formulas that we are going to derive from these two, zero and the coefficient. And so first one is sum of its zeros. So as we have said that alpha and beta we have considered as a 0, so if we sum it, we can represent it as alpha plus beta. So alpha plus beta, we can also write it as minus b by a. So b is our coefficient of x, and a is coefficient of x squared, right? As you can clearly see from here. So, and we have a negative here. So this negative is according to the formula. So alpha plus beta is equals to minus coefficient of x by coefficient of x squared. So this is our first formula. So now with this formula, I'm going to write one examples. So let's say our polynomial is given x squared minus 3x minus 4. A is the coefficient of x squared. So before x squared, there is nothing, means the constant number here is 1. And the b is the coefficient of x, which means before x we can see 3 with the negative. So negative minus 3 is our b, and c is the constant term. So constant term means the term which does not have an x. So that is -4 is our c. So now we know what are a, b, and c. So what we are going to do is we are going to take the formula alpha plus beta equals to minus b by a. So now substitute the value of A and B, which we know from this, right? So value of B is -3, A is equals to 1, and already we have a minus sign from the formula. So minus times minus is positive, and hence our answer is 3 by 1, which is equals to 3. All right, so this is our first formula from the zero and the coefficients, right? Now the second is the product of its zero. So now product of its zero. So as the name suggests, product means multiplication. So multiplication of the zeros. So alpha and the betas are our zeros. So we take the product. So if that is the case, then this product we can write it as C by E. So again, C is the constant terms, means which does not have the variable x. So this is our constant term, and A is again the same thing, coefficient of x squared. So we have an example here, P of x equals to x squared minus 3x minus 4, which is the same example we have done in the previous one. So our A and B and C are already taken out. So what we need to do is, we just need to put the value of C and A in the formula. So C is equals to -4, A is equals to 1. So -4 by 1, I can write it as -4. Okay. So again, one more formula we have, and that is quadratic polynomials. So this formula will help you to create a quadratic polynomials when you are given the sum and the product of the zeros. So let's say you are given that alpha and beta, which is the sum of the zeros, as 3, and alpha times beta, which is the product of 0, as -4, and you are asked to create a quadratic polynomials based on these two knowledge. So at such times, what you're going to do is you're going to use this formula. So x squared minus alpha plus beta times x plus alpha beta. So what you're going to do is, the first term x squared, you will just write it as x squared. The second is minus also same. Alpha plus beta, you're going to replace it with this 3. So it will become 3x, and alpha into beta, you will replace with -4. So plus into minus, it will become minus, and this will be your quadratic polynomial using these two, sum and the product of zeros. So the last topic of this chapter is to find the zero of a quadratic polynomial. So here I have taken one example, x squared plus 7x plus 10. And this is a quadratic polynomial because the degree of this polynomial is 2. Hence, this is a quadratic polynomial. Now I need to find the zero of this, which means at what value of x will this right-hand side converts into 0. Okay, so here I am using the middle term split. So middle term split, as the name says, the middle term of the quadratic polynomials. So always the middle term of quadratic polynomials will be the term which has the x, variable x. So this here, our middle term is 7x. So I have to split this 7x into two numbers, which when you add or subtract, I have to get back 7x. Okay, and there is one more condition, that is the same two number has to get this 10 times x squared, the 10x squared, when you take the product of it. All right, I'll repeat it once again. So you have to think of two numbers which when you add or subtract, you have to get the middle term, which is 7x. And the same two numbers which when you take the product, you have to get the product of first and the last term, right? So here I can think of 5x and 2x. And both 5x and 2x, if I add it, I am going to get 7x. Similarly, these 5x and 2x, if I take the product, I am going to get 10x squared. And hence, I can write this as x squared plus 5x plus 2x plus 10 equals to 0. So what I've done from this step is that I have just split the middle value. The rest, first and the last value, I have not done anything. I have just kept it as it is. The second thing what I need to do is from the first two terms, I have to take the common. So I can take the common as x. So x times x is x squared plus x times 5 is 5x. Now, the moment you have taken the common from the first two terms, next two terms, it is quite easy for you. What you need to do is you just need to take this x plus 5, the one which is in the bracket, you just take it as same over here. Now, what you can do is x times what is our 2x? X times plus 2. So plus 2 times x is 2x, plus 2 times plus 5 is 10. So the next thing is, again, you need to take out the common from this two, that is the one which is in the bracket, and the one which is not in the bracket, you just put it in this way. And thus we have got the x plus 5 is x plus 2 equals to 0. The next what we are going to do is, since we need the value of x, so either x plus 5 is equals to 0 or x plus 2 is equals to 0. So if x plus 5 is equals to 0, then x will be equals to plus 5. If you take it over here, it becomes minus. And this plus 2, if you take it over here, this becomes minus. So hence, these two are the zeros of the given polynomials. All right. So with this, we are done with this chapter polynomial. So the next video, we are going to solve the exercises questions. And thank you so much.